So let's introduce our next big money maker in DevOps. This is called Kubernetes. Kubernetes K8S. Okay, so K8S is also an acronym for Kubernetes. And you can see since AWS Cloud is our major cloud, we are going with the AWS service EKS. What does EKS stands for? EKS stands for Elastic Kubernetes Service. What is Kubernetes? That's the question. Why should you, as a DevOps engineer, master Kubernetes inside out? Why is it important? Why is it that 9 out of 10 organizations today deploy their workloads on Kubernetes? If there's one thing you need to pay attention to is Kubernetes, because Kubernetes is where everything that we have studied is going to wrap up to. Because what this is when we are now deploying applications directly into production, into the production environment. Kubernetes is going to expose us to all the skills that we have studied so far. Terraform is used to provision a Kubernetes cluster. And then you're going to start asking yourself, what is a cluster, right? Very, very important. Many dictionaries say that Kubernetes is a container orchestration platform, or it's a platform for the management of containerized applications. Okay. You want to take it very slow in a way that you're not going to feel rushed, okay? So in that definition, when you hear container, what comes to your mind? When you hear of containerized applications, what comes to your mind? Let's break it down. Yeah, Docker. So under Docker, what comes to mind? You see that? Because what? This is how you link everything together, right? Otherwise, you start becoming scared, right? So under Docker, what comes to mind? Because yes, Docker comes to mind. Excellent. That is correct. But then what comes to mind under Docker? What are the key features? No, bright. At this level, I can send you to the class that is coming up. You cannot say containerization. What comes to mind? I want to hear those key terms. Right? Don't forget that now you are at the advanced level of this journey. So your vocabulary, I expect them to be advanced. Okay? Already mentioned that Kubernetes is a container orchestration platform, or a platform for managing what? Containerized application. Then I asked, okay, what comes to your mind at this level? Someone said container, but again, what comes to mind? I want to hear all those terminologies. What those who have been studying throughout the week, what comes to mind? Under Docker, what did we see under Docker? What are the key elements or the main features that we saw under Docker? Didn't we see Docker images, right? We also saw what? Thank you so much, Eno. We saw what? Docker file, Docker images, and what? And Docker containers, Docker network, Docker registry. Thank you so much, Yumbu, right? So now what? So when you hear that Kubernetes is a container orchestration platform, it simply means that now we are what? We are no longer working with Docker files, but what? We are working with Docker images. So we have learned how to write a Docker file, okay? And a Docker file is what? It's a file that contains all the stages on how we want to build the applications. So in that file, we use all the keywords that we know of. In other words, Those words are also what? Known as instructions. Each instructions in the Docker file adds a layer to the Docker image. From Docker file, we are able to build the image. Where do we store the image? In. How do we call our platform? Where do we store the image? Where do we store Docker images? No, there is a platform for that. There is a name. Yep. Docker registry. Yep. But what? Docker image registry. That is the right name. That is the platform. Why? Because what? Under that registry, we can then have what? We can have different types of registry. Please, I want you to understand this basic concept. Docker image registry is not the same as Docker Hub. Docker Hub is a type of Docker registry. Okay? Under Docker registry, we have what? We also have the Elastic Container Registry, AWS. We also have the Azure Container Registry for Azure. And of course, what? We have the Google Container Registry for Google. So Kubernetes is that platform that is going to help us to manage, okay, our application. Manage the application. We want to scale, okay, the application. But above all, there is one benefit that Kubernetes brings on the table, okay? It's what we refer to as self-healing, because one thing you come to understand, as we saw, right, in the life cycle of containers, is that containers, once we create them, they are what? They get started, they are running, they die, they restart, and all of that. So now what happens when a container restarts? Yep, it's ephemeral, right? So therefore what? It has a short lifespan. So yes. So now, how then can we make sure that if we are running our applications in containers, right, we want to run it on a platform that guarantees 99.99% availability if the service. What does that mean? You know, from a business perspective, why do you think a business will care so much to have its application up and running 99.99% of the time? That's the first thing, right? So what? This is what the business wants. So us as the tech team, we have to what? We have to come to the table with the technologies that will achieve that objective. Do you understand what I'm talking about? Right? So MTN wants the MTN mobile money application to be up and running 99.99% of the time. Yeah, that's the objective. We call that in tech the service level agreement or the service level objective, right? From SLOs, we have SLAs. The objective, then we have the agreement. So let's say MTN and LionTech have an SLA. That SLA is referred to as the service level agreement. That's what the agreement between the service provider and the product owner. The guarantee is, or the agreement is, we want the mobile money app to be up what? To be up and running 99.99% of the time. It means that if we have two blackout in a year, it's a big problem, right? If any of you faces difficulty, let's say you take Cameroon, for example, right? Let's say, or even in Nigeria, let's say you are at a hospital and you want to pay a bill and you are paying this bill using MTN mobile money app. You do the payment, but the cashier is waiting for the receipt for the notification, confirm payment or payment confirmation receipt. So you're like, yep, I have paid the money. Please give me the receipt. Let me go and do my lab, or let me go get my medication, right? But cashier says, I'm sorry, I haven't received any what notification just yet, right? And all of a sudden, you notice that maybe there's an announcement saying that, oh, the MTN Mobile Money app is down. What do you think is going to be the consequences? Let's just say in a place like Lagos, if the payment gateways are down for an hour, right? So now you what? Now you understand the importance of what? Of 99.99% availability. This what? This availability is made available by a service called Kubernetes. So when we deploy our containerized applications on Kubernetes, we are what? We are assured of two things: high availability and self-healing. We are able to scale. In fact, we can what? So if you deploy an application, right, on Kubernetes, and you say, hey, you know what? This particular container, I want it to have 5 photocopies. Those photocopies in the Kubernetes vocabulary is what we refer to as replicas. If you're taking note, please take it down, okay? Replicas. So let's say what we deploy an app and we say, no, but what we want 10 replicas of this particular application to be up and running at all times. That's it, right? Is what. So that's what that is defined in a file called the Kubernetes manifest file. So how many types of files have we looked at so far? Terraform, .tf, right? Docker file, Jenkins file, and what? Now we're talking about the Kubernetes manifest file. So this is a file where we define, conditions for that deployment. How are we deploying this application? Do we want to deploy as pod? Okay, what is a pod? Pod. Okay, so what? Note this down. Okay, pod. I'll talk about this in my presentation, but I just want to let you know. All right, pod. So containers by default are what I deploy in pod, but pod themselves are ephemeral. Ephemeral means that we cannot guarantee our application when it is deployed in a pod. Why? Because the pod has a very short life cycle. If the pod is deleted accidentally, or the pod stops, or the pod dies, the application goes offline. Therefore, what? Kubernetes then offers another alternative. Then we start hearing of higher level objects or higher level workloads. Like what? Like replica sets, replication controllers, deployment, demo set, stateful set. Okay. Replicas. Those are what we call the Kubernetes workload. So every applications that we are going to be deploying in Kubernetes, every container is what? Is going to be deployed as workloads. Okay. And what are workloads? Right? Very slow. Okay. So therefore what? Kubernetes is a container orchestration platform, is a platform used to manage, scale, deploy, monitor containerized applications. Newsflash, as we're talking now, just go on Google and type what? DevOps jobs near me and look at how many times you will see what? Kubernetes, the ability to manage containerized applications. Those are listed as requirements. Okay. So Kubernetes is also what? One of those platforms that will introduce something very highly technical. For the first time, you are going to learn about ingress control, layer 7 architecture, transport layers in applications. What is layer 7 architecture? Okay, that Kubernetes is going to offer us. Before that, let's talk about how Kubernetes is going to introduce a new and the most advanced service discovery methodology or approach, right? Using what? Using Nginx ingress control, or using what we call ingress controller, right? And what we're going to use here is Nginx ingress control. So we deploy an application, we buy a domain name, we purchase a domain name, then what? With the help of creating A records, we are able to, configure service discovery using what? Using qualified domain names. So no longer are we going to be deploying our application using services like, I'm using what? Using IP addresses or trying to, access our app using IP. We can actually do that using an actual, fully qualified domain name. In this case, we call that, okay, service discovery. Okay. And so this is going to help you to answer the questions like, most interview questions are going to ask you, what happens when a client types facebook.com/login? What is happening in the back end? So at the end of Kubernetes, we are going to be able to implement this architecture. Please, everything I'm talking about now is what? Is action. You cannot describe these ones, okay? You can only describe it if you have done it. I get what I'm saying. Like, for example, someone asks, "Oh, can you describe your first 5 years in marriage?" If you've never been married, you will just be talking history or what you watch in movies. Okay? Not even 5 years. Maybe describe your first few days as a father. If you've never been a father, okay, you can only share the experience of others. Why am I saying that? I'm saying this because this is one area where you need to practice it. You need to master it to your fingertips. You can work for a company, and this is all you do, managing their workload on Kubernetes. Because what? This is where they make their money. When Kubernetes is down, it's a big problem. Okay? So in terms of the components, we are going to hear about what we call the Kubernetes control plane. Please, this is the Kubernetes architecture. Okay, yeah. Okay, we have what? The Kubernetes control plane, and we have worker nodes. This is very similar to the architectures we saw with the Jenkins master slave architecture, right? We saw that already. Very, very important. So with this, we have the the Kubernetes control plane, and it has its component. And what? We have the worker node and its component. This you must understand to your fingertips. What are these components and what are their roles? Because times you're going to go to, interviews and what? You'll be asked to explain the Kubernetes architecture. Yeah, you'll be asked to explain and to understand because sometimes, right, when you understand the architecture, it's like understanding how your car runs. So if you are driving and you start hearing some kind of sound coming from a specific component of your car, you have what? Because you understand how the car functions, you can easily tell. Or if you're driving and you see, a particular sign, let's say, okay, what? For example, with all these smart cars, you see high temperature, right? High what? High temperature on your dashboard. Okay? If you don't know, you want to drive until what? Until the car will catch fire. That's when you understand the consequence of what of that small warning you got. But somebody who understands is what is going to immediately what stop by the roadside, get out of the car. Why? because it's high temperature, right? The engine is hot. Okay, it means that what? It means that the supply system in or around what around the engine, the component that is supposed to supply it cooling is not working. What that component you called? Is it radiator or it's fan? I don't know too much, right? But I think it's either yeah, either of those. Right? Yes, is what. So it is the radiator. That's what. That is a very big problem. So if you stop at that point, what happens? You what? You save the engine. But if you continue to drive, what happens? The chances of your engine knocking out is very high. Why is this important? Now, if you deploy an application and say, oh, you know what? Okay, Kubernetes was unable pull the image from the registry. Maybe there's a 401 error. Now, what you can go to your architecture and you're going to look at, hey, okay, what component is responsible for what? For pulling that image into our cluster. That's called what? That is called a kubelet. And the kubelet is the kubelet found on the master control plane or on the worker node. See that? Okay, it's on the worker node. Therefore, what I have no business with what? With the master control plane. Okay, or with the control plane. We also call it what? We also call it the Kubernetes master. Okay, so we know that already. Okay, so on the master, we also have what? We have the Kube API server. The Kube API server is like the gate man. Okay, it's like so in terms of security as well, right? So what this is the component that filters traffic coming in and out of the Kubernetes cluster as a whole. Okay, we have what? We have the we have that there. So we have the Kube API server, and of course, we also have the Kube scheduler, the API scheduler. We have a couple of components on the master, as well as what? As well as the components on the worker node. So therefore, what? A Kubernetes is what? Is made up of nodes. Those nodes are what? Are responsible for running our workloads. Our workloads are deployed as what? As containerized applications. That means that, yeah, Pascal, I've read the PDF I sent. So if you've read the PDF, you're going to understand what I'm talking about, right? Because everything is there. Of course, what? The etcd is what? Is a data store. So it's like, it's more like a mini database. That what? That records what's happening in our cluster. Okay, the etcd and all that, right? So, in summary, Kubernetes is so important in every software development operations because what this is the final platform where we deploy our applications. So, therefore, what now? If this is where we are deploying our applications, therefore, what you must think broad and wide. You must think about security. Okay, how do we administer the Kubernetes cluster? This is why there is what? There is a course and what? And a certification for what? For certified Kubernetes administrator, right? Certified what? Certified Kubernetes administrator. That's a course that you can go in for if you decide to back up the skill. In fact, that's what if there are two certifications that I'm going to strongly recommend, okay, that you're going for this course going to what is going to be CKA and Terraform. Because what? Those are very specific. Terraform is what? Infrastructure. Very good with that. And of course, what? It also comes with cloud. And Kubernetes is containerization or container orchestration management. So you can copy your skills with those two. Okay? Talk about that. Very, very important. Anybody have a question so far? So you also hear about the concept of what? The concept of services in Kubernetes, okay? Services, we have three types of services in Kubernetes, all right? We have what? We have cluster IP service, we have node port service, and we have load balancers. What did I say? Cluster IP, node port, and load balancers. Interview question. What is the difference between what? Between cluster IP and node port, right? What is the difference between node port and load balancers? Very, very important. Okay. Now, what is the difference? So now, when we deploy containers, right, when we deploy our applications as containers running in ports, we are going to use higher level objects to manage those ports. Okay. Now, those containers in those ports need to communicate in the cluster with each other. How do they communicate? So, internal communication is what is made possible with the help of cluster IP service. That means that nobody from outside the cluster, nobody can access the application. Why? Because it's what? It's what? It's meant to what? It's meant to communicate from within the cluster. Now, I want you to understand something very, very specific here. So if all our applications that, so let's say what? Let's say you deploy a banking application with 50 microservices, like 50 features. Each of what? Each of those features has what? Has to communicate with the next feature. For example, account creation must what? Must communicate with authentication. Authentication must what? Must communicate with transfer, right? So we have all of these components of that application that what? That needs to communicate with each other. So in the cluster, that is made possible by a service called cluster IP service. Hmm? The next one, the next service is what? Is node port. Node port is just a set, a range of IP addresses, and I think it's from 30,000 to what? To 32,500. So any IP address that we assign, right, in that range is qualified as a node port. And so the application can what? Can be accessed with the IP address of the node and what? And the node port, we are going to be able to see our application. But there is a risk with that. We cannot use that in production. Maybe, in development environment, okay, yeah, that's fine. Not too bad, right? In test, okay, it's still internal. But you can say, hey guys, I've launched my application. This is the node port, that's the IP address. No, right? That's not going to work. The next service is the load balancer service. The load balancer service, when we deploy our application with service type equals to cluster IP, we what? We want communication to be internal. If we say service type is equals to node port, we want what? We want to expose that application to the outside world. If we say node service type is load balancer, we want to again what? Expose the application to the outside world. So what is then the difference between node port and load balancer? Node port is what? Node port gives us a range of IP addresses from 30,000 to 32,500. So any IP that we pick in that particular range is going to qualify as node port, and we can access the application from outside the cluster. Load balancer is the final one. Okay, and that's what we are going to use load balancer to configure our DNS. What is DNS? Domain naming service. Every application has a domain, isn't it? If you look at Facebook, what's the domain of Facebook? Facebook.com, x.com, Twitter, twitter.com, right? Instagram what? .com, MTN, mtn.ng, mtn.cm, mtn. Right? Those are what? Those are all domain names. So when you type those domain names, you are able to access the service. But then in this particular session, you will understand the networking of what happens when what? When you type any domain name, you are not talking to the service directly. No. Like what we are going to see, right? That's why I sent you guys a diagram of the level 7 architecture, right? Like that. So you're going to see that our load balancer. Now, of course, what? So this is where also your knowledge of what of architecture now comes into place. Yes, we're going to deploy an application. Where do we place what? Okay, of course, it's going to be deployed in a VPC. In this VPC, right, we have subnets. Private subnet, public subnet. In your knowledge and drawing inspiration from what we did yesterday, what do you think should be in the private subnet? What should be in the public subnet? So if we have a load balancer and we have our EKS cluster, where do you think the EKS cluster should reside? Public subnet or private subnet? Okay, private subnet. Okay, so, of course, so now our EKS cluster, rightfully speaking, is what is going to reside in the private subnet. Then, of course, what? The load balancer is going to be in the public subnet, okay? So when you hit www.com. Let's say, nexusapp.com, what happens? You're going to first of all interface with the public subnet. And then there is a mechanism in place. That's where your Nginx ingress control comes in. Is what is interfacing between what the load balancer and the EKS cluster. We are going to see this, and it's so interesting that I don't want to miss any part of it. And if there's anything you want me to repeat, please let me know. I'm going to repeat it. But Kubernetes is a beast. It's so broad, but it's also so interesting. And if you understand it from the start, you are going to enjoy it, right? So let me summarize before I go into my slide. In the slide, you will understand. And I've also shared the PDF document. Let me see. And yeah, I think if you person just join the group now, so I'm just going to share it again. But you're going to see there were the PowerPoint for Kubernetes has been shared. You're going to see it's a must read PDF document. Please read it. Okay. So just that you read the document before you even watch the videos, okay, so that you can know what we're talking about, okay? So in summary, right, Kubernetes is a container orchestration platform. What that means is that we use Kubernetes to manage our Kubernetes, our containers application, okay? So what that means is that what do we mean by manage, okay? Scaling the application is part of managing. Okay, redeploying the application is managing. You want to roll back is managing. You want to what you want to roll out. So what we are going to hear about what now we're going to hear about deployment strategies, right? Again, what only in Kubernetes you learn about what about deployment strategies. Let me ask you a question. So let's say you have version 1 of your application. Okay, payment methods, PayPal, versions 2. Payment what method is now updated. PayPal, Visa, and okay, uh, mobile money. You get what I'm saying? So now the question is, how how are you going to update that particular application to versions 2 without experiencing a downtime? Are you going to use the recreate strategy? Of course, what the name itself, recreate means what? You have to, okay, first of all, kind of destroy, then create. The interface, that time, okay, the minutes between that destruction and creation, that blackout there, what is a blackout in production? Do you want that? The answer is no. We also have the what? The rolling update strategy. Okay, rolling update is okay. You know what? Since we have this, we can deploy 25% new And what? We take out what? We take out 25% old. 25% new, 25% old. We'll talk about this in depth, but I just want to give you an overview, right? That's the second one. The next one is what we call blue-green, right? So blue can be the new one, and of course, what? Green can be the incoming, right? So you can see, of course. So once you declare that your strategy is what is blue-green, what happens? Kubernetes automatically adjusts the way it's going to manage, right? Therefore, what? It's not going to give you any form of downtime. Never, right? That's also a very, very important stuff. So we have deployment and deployment strategies. How do we deploy our application? How do we update the application? How do we manage? That's why we say Kubernetes is a container orchestration and management platform. We are managing Kubernetes workload. This workload will appear as what? As ports, deployment, replica set, application controller, daemon set, and stateful set. Even secret services, DNS. There are a lot of services or workloads that we are going to see, okay, in Kubernetes. So I've talked about services, the workload, okay, the cluster, and of course, what the Kubernetes architecture, the master control plane, and the worker node, and all its components. We'll look at that. And somebody was asking a question. Okay. Oh, don't worry about that one. That's too far. I'm not going to get in there for now because what we are going to get there. We are still at the level of the introduction. But this is how the load balancer, okay, functions. No, let me not go in there for now. Okay, forget it. I won't do that. Okay, this one. Now, let me quickly go through my presentation. Then we are going to go do some installations and take it from there. So of course, what we are introducing Kubernetes. So we'll talk about the architecture, the core components, and of course, what we'll deploy our first workloads. Okay. And yeah, so of course, today we'll cover what is Kubernetes, the cluster architecture, control plane versus what worker node, the core objects, okay, port deployment service, how the reconciliation loop works, basic kubectl workflows, look at all of that. So again, what? So I already spoke about this. So why Kubernetes? Scheduling. Okay, Kubernetes solve common problems when running containers at scale, right? When we're running containers at scale. The first thing is scheduling. You want to be able to schedule ports. Now let me ask you a question again. What runs in the port? So when you hear about, schedule port, what runs in the port? Based on my introduction, what runs in the port? What runs in the port? What do you think is in the port? Because it's so important for you to understand, right? What runs in the port? So therefore what? They what? Yeah, thank you so much. I know the containers run in the port. And of course, what the port is the basic unit, the most smallest unit of workload in Kubernetes. But also what? It is the fundamental. Okay. This is what controls and manages our container application. But there are some issues with the ports. Ports are ephemeral. That means that they have a very short life cycle, right? They can die and they have no mechanism to restart. Okay, they have no mechanism for auto scaling. They have no mechanism for self healing. They have no mechanism for scalability and all of so that in itself gives the port limitations. That's why you hear of higher level workloads. Now, being able to use deployment to manage port, use replica set to manage port, use replication control to manage port, use daemon set to manage port, use stateful set to manage port. See that? Do you understand? Am I too fast, by the way? Am I too fast? Therefore, so the port, okay, the port is the basic unit of workloads. Please remember, workload is a term, it's a vocabulary in Kubernetes. Write it down. Port is a vocabulary. Write it down. Pod, not pot. Pod, okay? And all of these workloads have their syntax. Okay, you cannot say port with lowercase p. It has to be capital case P. So if we are writing a manifest file for port, please note this down. Kind, okay? Under the section of kind, and you're saying your kind is port, you can't say your kind is port, lowercase p. That's why it has to be uppercase P. Okay? Very, very important. Are we there? Are we clear? Any questions on that one? Are we clear so far? Everything good? Okay. Good. If you understand type 1. Okay. So now, okay, so port in itself, when we deploy application just as containers, as we saw with Docker, what we face issues that has to do that revolves around scheduling, self-healing, scalability, self-discovery, rollout, and portability, right? Very, very like we saw. Okay, in order for us to update a container, we have to first of all delete the existing container before we roll out a new version. That's what that is. That's creating a downtime, right? It means the application is going to go offline for some minutes or for some hours. We don't want that. So that is a limitation, and that is what Kubernetes is solving for us, right? That roll we can what? We can roll out what with zero or low downtime. We cannot do this alone with Docker. Service discovery and what? Stable networking and load balancing to reach each port. This is only done in Kubernetes with what? With the help of services like load balancer and what? And ingress. Scheduling. We're going to learn about the scheduler in Kubernetes, how it schedules port to run on the best node based on resources and constraints. So now this is it's like so we have a cluster, right? And we have nodes in those clusters. Those nodes, let's not complicate our are just what again? They are just what? Computers, okay? Servers. That's what we call nodes. So in Kubernetes, what we refer to computers as nodes. Okay. One node, two nodes forms a cluster. And this is one node. We call it what? We call it a mini cluster. So you can have a cluster of one node. Okay? Is it clear? So self-healing is what? Is when container restarts, right? When container restarts, and all of that. Without Kubernetes, if a container restarts, okay, it's not going to come back online with the same details. But with Kubernetes, we are sure of container restarting in a way that it's going to come back on. In fact, if you delete, right, if you delete a container, it's going to come back. But if it is just on Docker, is it what happens? That container is gone with all the data in it, except you have configured some kind of volume management, right? But in Kubernetes, we're going to see when you deploy a container in a pod and you kind of configure your manifest file to include replicas, right? If you delete that pod, what happens? Kubernetes in less than 1 second is going to automatically recreate that pod. That is what we call self-healing. In Docker, we do not see that. That means that in Kubernetes, we are assured of our applications running at least 99.99% of the time. Is it clear? Okay. 1 second. I'm trying to see this diagram. I think I have posted it in your chat. I think if I put it up, it's going to be better. It says, okay, okay. One it is, okay. It's okay. I'm trying to see that. Okay, what is cool? I think I have that. I posted it on your stuff here. What is this? Let me see. Okay, no, I think it's clear. All right. Can you guys see this? Therefore, what? So if you look at says what Kubernetes is an open source platform to automate what? For what? Automating the deployment, scaling, and what? And management of containerized application. Okay. So therefore, what? First, it's an open source platform. So and so if you come back here, type what? If you type Kubernetes here, right? There you go. See that you're going to see it says what? Is an open source platform designed to what? See that? Automate the what? The deployment, scaling, and management of what? Of containerized applications. It was what? Originally created by Google in 2014 and now is maintained by the Cloud Native Foundation, CNCF. It orchestrates clusters of virtual machines or bare metal servers and what? Facilitating container orchestration, self-discovery, load balancing, and self-healing, auto restart and rescheduling, right? Now what? Look at the features here, okay? Key features of Kubernetes. Container orchestration means what? Just means it manages container lifecycle across multiple or distributed nodes. Now we know that our cluster is going to be made up of nodes. Okay, more than one node is a cluster. Even just one node is a mini cluster. But what we are going to have clusters of X amount of nodes. Okay. Auto scaling means what? It scales application containers up and down based on resource demand. Good. This is January. Which business do you think is going to be scaling down, just coming out from the holiday period? And which one do you think is going to be scaling up? You see those ones following the class. Okay, and who can complete? Uh, yes, that's going to be boutique, right? Yeah, of course. Yeah, Christmas dresses. Of course, what? Yeah, that's right. Therefore, what? Yeah, that's true because now everybody is what? Everybody have entered what? Everybody have entered gaming. Okay. People are paying their debt now. All the drinks you give your friends during the Christmas period, you have to pay for it. Right? Yes, of course. So now, when we talk about scaling, what do we mean? So let's say in December, you were running what an e-commerce application, right? Of course, December periods when things are all right. So let's say you were running what T3 large, okay? T3 large, let's say 40 gigabyte of memory, right? Of course, what that 40 gigabyte of memory was justified in December. Nice January, traffic is low. You go for like uh, maybe one day and you have just like 5 orders. Do we still need to have 50 gigabyte of memory on that particular server? The answer is no, right? So can we have a system that that particular resource, in this case, the memory can what? Can automatically scale based on what? Based on traffic. So hey, if what? If memory consumption is approaching X amount, okay, scale our memory. If it is dropping down and drops to X amount, okay, scale down the memory. Now that's what? That is automatic what? Automatic resource management because the servers we deploy, okay, comes with metrics like what? CPU consumption, okay, and memory consumption, network IOs, and all of that. Very, very important. Therefore, what? You see that auto scaling. What does self-healing means? It means that what? Automatically restart failed containers, replaces them, and what? Reschedules them when the node dies, or and what? Kills containers that do not respond to health checks. Okay. Let's say you have 5 nodes in your cluster. One of the node dies. It means that what? So that it's like you have, okay, let's say you have a cyber cafe, okay, with 5 computers and you have different applications on. Or let's say you have one person working on that particular computer, right? Of course. So now without some form of, auto scaling, right? Or self-healing, it means that if that container dies, if that computer dies, what happens? Everything that was running on it is going to die with it. But what? The master control could what? Could detect that. Why? Because what? At all times, the master is what? Is sending signals to all the nodes every second to see if they are alive, right? If they can receive workload and if the workload on those nodes are running. So even when the master realizes that a node, a computer, a server in that cluster is failing health check, what happens? It automatically what? Reschedules all the applications running on that particular node to a different node. So what? That's a year what? So when you hear about health check, it's like, hey, are you alive? Are you okay? Are you okay? Are you alive? Are you breathing? Do you still have enough resources? So what? There are a couple of factors that can lead to a server failing health checks. For example, a server is overlooked. Okay, memory consumption is running very low. It's going to fail health check. That means that what the master will not be able to schedule nodes on that particular server. Why? Because what? It doesn't have enough resources. You run health check. That's how do you know that most of your HR managers run health checks, right? So if there's a particular shift, they call and say, hey, are you able to lift maybe 50 pounds? Okay. Are you okay with lifting loads up to 50 pounds? Say, yes, ma'am, I can. That's a health check. Okay. Because if you say no, I cannot, say, okay, thank you so much. They move on to the next person, right? That is a health check. You want to be sure that this particular component is up, is healthy, and all of that. So self-healing, okay? Automated rollout and rollback. I've already explained this. Manages changes in applications configurations progressively. It's like I can ask you this question. Let's assume that you want to upgrade your memory from 8 gigabyte to 40 gigabyte. How can you do that without experiencing a downtime, right? Like that. So that's a big question. Okay. So automated robot with application is something that you are going to do this. So in the normal working environment, okay, we do this. So depending on your Scrum Master, okay, Scrum Masters and what depending also on the type of applications that you are working with, most organizations do what we call updates to their application like every 2 weeks. Okay, we call that iterations. Okay, or let's at the end of the sprint because Softwares are developed using methodologies. Okay, so we have sprints, and in the course of the sprint, you have Scrum ceremonies like daily stand-up meetings. You have tickets that must be completed. So you have tasks that's assigned to each member of the team. They are all working, so they have a 2 week goal. Let's say, okay, the 2 week goal, at the end of the 2 weeks, we want to add a new feature to our app. So at the end of that, then what DevOps needs to deploy that new feature to production, right? Well, let's say there was an issue with an existing feature. Now the issue has been fixed. Now we need to update that particular feature, right? In the course of doing that, we call it rollout. Rollback is when, let's say, okay, we deploy a feature, and then this feature is what? It's not functioning as we expected. We can what? We can roll back. How many of you have done something new with WhatsApp plates? Right? That's what that is, a rollout. So when companies roll out new features to our application, that is a rollout. And if they roll out and discover that, you know what? Oh no, this particular feature is giving us issues. We have experienced this in HP, I think last 2 months. We did a rollout on Wednesday, and of course, what? Immediately after the rollout, we began getting notifications of what? Of high memory consumption. It was a dangerous signal because what? That meant that the application was going to fail at some point. Now, this memory consumption was not linked to high demand because, of course, if let's say, okay, we deployed a new feature and all of a sudden we have what? We have, 1 million customers, okay, purchasing devices and all of that, then that is justified. But when the memory consumption we couldn't link it to increase in the amount of traffic. It means what? Something was leaking in the code. So that had to be resolved. Therefore, what? Now, do we want to leave a feature that is not working or that is breaking our production? The answer is no. So what? We simply what? We simply roll back. Then what? We roll out the previous working version. This is where you're now going to also what? Appreciate versions control. Git. Hmm? I think we are following. Is it clear? Is it making sense at all? Everyone? Are we making some sense? Okay. All right. So therefore, what? You want to what? You want to roll out, and also, so what? We roll out changes or features. Then what? We roll back features that are not working. Okay. Then, of course, the control plane. Okay. Then what? We know about the storage orchestration. So what? Kubernetes also offers what we call storage orchestration, automatically mount storage system, local, public, or cloud. Okay. And in terms of the core architecture components, we have what? I spoke about the control plane that comes what? It's the brain of the cluster. And of course, what? It consists of the kube API server, etc, which is the data store, the kube scheduler, and what? The kube controller manager. The worker nodes, they were the individual machines, virtual or physical, that run the application containers containing what? Kubelet, the node agent, the kube proxy, network agent. Port, they were the smallest deployable unit in Kubernetes, containing what? One or more containers. So therefore what? Like I just mentioned earlier, we deploy our containers in port. Okay, we're going to see this, okay, in a very practical way, don't worry. Of course, talking about use cases, microservices management, you want to what? You want to simplify what? Deploying and operating what? Complex container-based microservice-driven applications. Hybrid multi-cloud enables what? consistent deployment across on-premise and various public cloud environments like AWS, Azure, GCP, CI/CD optimization. This is our final goal. The moment we implement this project, you're done with your program. Okay? The moment we are able to build, deploy, test, scale and deploy into Kubernetes, and then implement monitoring, what you are done with your program. As a matter of fact, when we're done with Kubernetes, okay, you have my blessings to put your resumes online because now you have something of value to sell. You have the story you can tell, right? Very important. Okay. Make sense, everybody? So it looks like there is something called AI ML workloads. That manages conversational resource required for intensive AI. Okay, don't worry about that. So what? This is to tell you something about technology. Technology keeps evolving every day, right? Before we know it, we're going to see what? We're going to start seeing AI being what? Being implemented directly into Kubernetes. That means that if your app was to go offline, the agent can automatically just solve that issue for you. Okay. But again, that's where monitoring comes in. I think we're going to see that in monitoring when we get to monitoring. Okay. So yeah. Anyways. Okay. So therefore, that's what. So that's the diagram that we're explaining, right? What is Kubernetes? It manages what? Containerized apps. It keeps application running consistently across clusters of servers and cloud, right? And then of course the control plane we can see there, the API server, the etcd, the scheduler, and what? The controller manager. Please what? We have four major components of the control plane. The API server, it validates requests, changes, and desires. So let's say what? If you run kubectl apply abcd.yaml, right? Of course, what? That request is going to go through the API server. So now, if you apply that command and you get an error message, or let's say what? For example, let's say you get a permission denied. It means that what? It means that Kubernetes said, no, you know what? I don't know who you are. But what component that the component there is the Kube API server. The etcd is what? Is a key database holding what? Cluster state information. Scheduler what? Assigns port to run on node. Okay. And then we have the worker node, which contains what? The kubelet, container runtime engine, kube proxy, and the CNI plugin. And then you have then of course what? Container orchestration, everything that is defined and all of that. Okay. I don't think we have to talk about this again, but yep. So you can see kube proxy, your port runs on the node. So this is how it works, right? We have the worker nodes, and then of course on the worker nodes, we'll deploy our container. That container what is going to be made is going to be deployed in a port. Now we can manage that port using deployments, replica set, daemon set. We'll talk about all of that as we progress. This is just the introduction. Okay, now, as you know, it's always good to define this. It says what? The kube API server is what? Is the front door of the cluster. It validates requests and exposes the Kubernetes API. Okay. etc, the key value store for all cluster state, desired and current. All right. Kube schedule it what? Chooses the best node for new port based on resource and constraints. So when you run kubectl apply, maybe you want to deploy a new application, the component of the architecture that decides which node is going to accommodate that application is called what? The kube scheduler. Is it clear? Then we have the kube controller manager. It runs controllers that reconcile states. So we have deployment, for example, node and endpoint. Talk about this in details as we, okay. Cloud controller manager integrates what? Kubernetes with cloud resources like what? Load balancers, volumes, and route. Okay, I spoke about this area in my intro. So then of course what? Just remember that what? That every kubectl or CI request goes through what? The API server first. So we are going to see, so the way we interact with our Kubernetes cluster is programmatically through the kubectl client. In the next phase of the class, we are going to install kubectl, we install, okay, all the Kubernetes components that we need in order for us to run Kubernetes. And these are also your onboarding requirements. So if you are going to start working for a company that requires you to work on Kubernetes, they wouldn't tell you what to install, right? You need to know what to install. If you are going to work on Kubernetes clusters, you need to run kubectl commands. Therefore, you need what? You need to install kubectl on your Windows computer or on your Mac, yeah, on the Linux server. Well, the worker nodes components. Please, okay, anyways, this PowerPoint is available as well. We have what? We have the kubelet, the container runtime, the kube proxy, and what? And the CNI plugin. One of these. The node agent. Okay. Ensures that what? Ensures that port describing the API are running healthy on this node. That's the kubelet, okay? It's the node agent. So the kubelet is sitting on the node. We have the container runtime that what pulls images and runs containers on the kubelet. So when you mention Docker, you were right. But the component, what it is called in Kubernetes is what? Okay. How do you pronounce this? Okay. Right. It's container D. Okay. It's not container. Okay. Because some of you are so funny. You call it container. Okay. So the component responsible for pulling images. What images are we talking about here? What images? Right? Docker images, right? Pulling what? The Docker images is what? Is container D. Okay, so that is the component that is responsible for what? For pulling images and all of that. Okay, and runs containers for the kubelet. So if container D is not working, kubelet is not going to work. That's why we call it an architecture. It's more so a system. Okay, if that makes sense. We have the kube proxy. It implements service networking, IP tables, IPv rules to what? To route traffic to ports. That's what somebody was asking earlier, right? Load balancing. When you're about routing, it's load balancing we're talking. Then we have our CNI plugin. It what provides port networking, IP allocation, route on EKS, okay, Amazon VPC CNI, and all of that. Workload. So let's start with these three for now. Most beginners workflows built on them. We have port deployment services, okay? So these are what we call Kubernetes object, but this is just the first three, okay? Port deployment and services. Okay, so port is what? The smallest deployable unit. Okay, and of course what? It contains one or more containers. It shares what? Shared network plus storage. Okay, that's port. Spoke about that already. Deployment. It manages what? Replicas of port, rolling updates, rollback, keeps what? Desired number running. Very, very important. Now, do you now see that what? We use what? We use deployment to manage ports and import. So what runs in port? It's so important because you'll discover that when you are running, okay, when you're deploying your app, right, using deployment, for example, right, you're going to say, what? Okay, you're going to say replicas is equal to 5. That line in your code is what? It's talking about high availability. So at all times, you want what? You want to have 5 replicas of that exact application. That's what we're talking about, okay? Services, very, very important. Stable virtual IPs, load balancers to port and what? Select port via level. So we have services. We'll talk about all of these as we progress in this. We're going to talk about them component by component, okay? So how Kubernetes workloads, okay, works or reconciles the loop, okay? We have first one, right? Or YAML file, okay? You can see you apply a YAML, then what? The state stored, controllers act, scheduler assigns, the kubectl, kubelet what? Runs, and the networking and health check is done in the background, okay? So basically, okay, whatever, port what? So port are not servers, just a couple of things to know. Missing resource requests. Schedulers what need requests to place ports intelligently. So they need a request to put in place. No readiness probe. Traffic may hit an app before it is ready. Okay. Hard coding configurations. Use what config maps, separate instead of baking what configs into image. So now these are high level advanced concepts we're going to see. If your application requires environmental variables, password, secret, access keys, credentials, all of that, how do we inject that in the application? We want. That's what you're going to hear of config maps and secret. Then, of course, what? Ignoring namespaces. Okay, so this is introduction to Kubernetes, and we will take a 10 minutes break. When we come back, right, we are going to look at setting up our Kubernetes environment. So we need to install a couple of things. Then what? We create our very first cluster. Then we start deploying our workloads. So if there is something you are supposed to write down, is of course what? Oh, don't worry about what you're seeing on my screen. Oh boy. Okay. Let's keep this here. All right. Therefore, what? If you are taking notes, once we have our cluster ready, we're going to talk about workloads. Okay, the types of workloads that we deploy in our cluster. Make sense, everybody? Yes. Let's take a 10 minutes break. When we come back, we're going to continue with those installations, and we are installing on Windows. Interestingly, so at this level, everything we install is on your Windows computer. How do you find those installations on your Windows so interesting? It's interesting because what? Because no, you don't need to think twice to work, right? Everything is just there. So as long as your computer is up and running, you are good to go. Okay, because what we want you to work with your bare metal to understand how these things work from that level. Okay. So I'll see you in 10 minutes and then we'll take it up from there. All right, everyone. Thank you so much. I'll see you in 10 minutes. Bye bye bye.